Hello everyone. Now we're gonna see some numericals for the superposition of the wave. So I'll try to dictate the question here so that you find it easy to follow. So now the first question is write the equation of the simple harmonic progressive wave of amplitude 0.02 meter and period 0.045. Okay. Now 0.04 second. Okay. Traveling along positive x direction with velocity. So you have amplitude. Let's say I denote amplitude with a capital A or small a, depends on how you are using it. 0.02 meter. Then let's suppose I want to write time period is now time period is already given. Now time period I can write in terms of the 0.04 second, and velocity when it is traveling in the x direction, so it's 12.5 meter per second. Now you must be aware about the basic principle of writing the simple harmonic equation. So what is the most generalized way of writing the equation, harmonic equation, progressive equation basically? Now it is going along the positive direction. You have to make along the positive x. So for the along the positive x direction, we have a sine 2 pi, what is it, t by capital T minus x by lambda. So this is the most generalized equation. Okay, you can simply find this equation. So rewrite this equation in terms of the velocity so that you can actually write in terms of the velocity, or you can calculate the lambda separately. So what is lambda basically? So lambda is nothing but the velocity into time. ओके क्योंकि वेलोसिटी क्या है, वेलोसिटी डिस्टेंस बाय टाइम है, तो हमारे पास वेलोसिटी दिया हुआ है, सो इट्स 12.5 इंटू टाइम 0.04, oh sorry 0.04 right, yes 0.04 second, so that should come 0.5 meter. Now if I just continue this, so I have amplitude is given, so I have this value here in front of me. Now time t is given, or no, we have to write in terms of the generalized form, remember this. So you have all the information given now, so y is equal to a 0.02, what is it, sine 2 pi in bracket. Now at some time t, when time period is 0.04 second, at some displacement x, and when wavelength is 0.5 meter. So that's how you write actually. Okay, so this is actually very simple 1 mark question. So by just looking at the information, you should be able to do this thing. This was just starting point. Now let's try to continue with the next numerical. Now the next question, the question is a wave frequency of 500 hertz is traveling with a speed of 350 meter per second. So keep in habit of writing all the information whatever you have in the beginning itself. So what is it, what is that we have, n is equal to 350 hertz frequencies, right, and velocity it is nothing but 350 meter per second. Oh sorry, velocity this is 500, so frequency is 500 hertz. Okay, now in that case, now let's continue. What is the phase difference between two displacement at certain point at time 0.1 second apart? So there is a particular time given and you have to find the phase difference. Okay, so first thing you have to do is find the relation between this. So if you remember the formula, you can just directly apply the formula, or there's always a nice way of getting the formula also. So whenever you have you should be remember that we actually discussed this, that if you are sector formula में हमने x when we did the theory part, we actually derived what is the displacement. So I'm not going to derive for the x here, but here I'm going to derive for the phi. Now let's suppose this is a phi. So when you actually cover this much distance, okay, let's suppose you take t time. Okay, so you can simply say that that I have phi per time, some time t. So when you complete this phi is equal to 2 pi, you actually complete one time period. Okay, it's just a proportionality thing, so you can actually derive it instead of remembering these things. So phase difference is nothing but 2 pi some time t at capital T. Now I think all the information is given now. So at some time, now the question is what is the phase difference between two displacement at certain point. So they are asking a certain point at times 0.1 millisecond apart. So basically what you have to do here is you just have to substitute what is phi. So 2 pi by capital T into some time t. Okay, so 2 pi by t into some time t. Now this is what this is 2 pi into n, correct? It is nothing but the 2 pi into n. Now n frequency is given, so 2 pi into 500 hertz into which time they are asking, millisecond, how many millisecond, okay? So they are asking this at 0.1 millisecond, so 0.1 into 10 raised to minus 3. So please do this calculation, okay? So millisecond is to minus 2, yeah. So complete this calculation, and you should get something around pi radian basically, okay? So if you just do this, okay, 5 to the 10, it is pi into 1 10 raised to 3 into 10 raised to minus 3 into 0.1 second. So this get cut and we have pi into 0.1. Okay, now okay, so as per the okay, and correct, pi into 0.1. Now oh, it's 1 millisecond, right? I think for the given information 0.1 millisecond. Oh, 0.1, okay, correct. So 0.1, fine, so that's correct. So it's 0.1 pi radian. Now question in the question number 2, what do I need? What will be the smallest distance between the 2 points which are 45 degree out of phase at an instant interval of time t? So it's actually fine, you just have to calculate the displacement. So smallest distance, they are asking distance, so you should be able to figure this out from the numerical itself, okay? So distance kya x, so we already derived this formula. What is it? X is equal to lambda by 2 pi into phi. We have derived in terms of the theta. So please recall this equation, and it's actually very simple. We just compare the wavelength and the displacement, okay? For the x displacement divided by lambda displacement, phi or theta cover divided by 2 pi cover, because this is nothing but this one, okay? So if I'm just giving you a quick recall how we derived it. So x is equal to lambda into, what is it, phi by 2 pi, okay? So now what is the information we have here? So they are already giving you 45 degrees out of phase. So remember, this phi is different than the previous one. So lambda by 2 pi, now I'm keeping everything in terms of radian because everything in terms of radian. Now don't write 45 degree, okay? 45 degree is equal to pi by 4 radian. So please make sure you don't do this mistake. So this pi get cut, and x is equal to lambda by 8. So that's actual distance. Now what is lambda? But did we calculate lambda? So can we calculate the lambda from here? Okay, so what how do you calculate the lambda? Basically lambda is nothing but the, okay, how do you calculate the lambda? So lambda is equal to v by n, and lambda is equal to, what is it, 350 by 500. So just substitute it here. So x is equal to lambda by 8 is equal to 350 divided by 500 into 8, कट हो जाएगा 7 5 85 by 80, 8.7 something. Okay, please complete this centimeter, or you should get 0.087. okay, the answer what I have is right now 0.0875 meter. Okay, so this is how we actually calculate the numerical. Okay, in next set of the video we will solve more this kind of numerical.